All right, this time we're going to cover questions 20 and 21. Most savings institutions offer compounding intervals other than annual compounding. For example, a bank that offers quarterly compounding computes interest on an account every quarter, that is, at the end of every 3 months. Instead of computing the interest once each year, interest is computed 4 times each year. If a bank advertises that it is offering 8% interest compounded quarterly, 8% is not the actual growth factor. Instead, the bank will use 8% divided by 4, which equals 2%, to determine the quarterly growth factor. Number 20. What is the quarterly interest rate for an account with an annual interest rate of 5% compounded quarterly? So if that were the case, we would do 5% divided by 4. And 5 divided by 4 would make that 1.25%. Suppose that Madison invested $10,000 in an account described in item 20. In the table below, determine Madison's account balance after the specified times since her initial deposit. 3 months, 6 months, 9 months, 1 year, 4 years, and T years. Well, how many times, number of times interest has been compounded in a 3-month period would be 1 time. 6 months, that would be twice because it compounds every 3 months. 3 months would be 3 times. And in 1 year, if it's compounded quarterly, it is compounded 4 times in that year. In 4 years, that would be 16 times, sorry. And if we did T years, that would be 4T. Now, if this were the case, we would be doing 10,000. Instead of our interest rate being that 1 point, or our growth factor being the 1.05, here it's going to be 1.0125, and it's going to be raised to this power. So here it would be raised to the 1 power, the 2 power, the 3 power, the 4 power, the 16th power, and so on. So we're going to do 10,000 times 1.0125 to the first power. So our balance in our account after 3 months will be $10,125. After 6 months, it would be $10,251.56. After 9 months' time, which is 3 compounds of quarterly, that would be $10,379.71. After a year, we would have $10,509.45 in our account. After 4 years, it would have compounded quarterly 16 times. We would have $12,198.90. Here, our exponent would be 10,000 times 1.0125 to the 4t power, depending on how many years we compound this. B, Write a function A of t to represent the balance in Madison's account after t years. So we just set this expression equal to A of t. A of t equals 10,000 times 1.0125 to the 4t power. So whatever the number of years is, we're going to multiply it by 4. Calculate the balance in Madison's account after 20 years. Now remember, t is 20. So we're going to do 10,000 times 1.0125. And up in my exponent, I'm going to do 4 times 20. That gives me $27,014.85. Oops, sorry, you couldn't see my amount. I apologize. Go ahead and take a moment to get your chart copied down here, and we'll move on to the next section.